A very warm welcome to the second recitation of CS 170. Today's topic is number conversions, hexadecimal, decimal, and binary conversions. So before we start today's recitation, I would like to point out a few things. You can find the presentation file under the Files tab under Recitation Information under my name, Jayashree Damota. Also, please make sure that you watch the recitations every week and fill the Google form. The link is always present in the PPT file. The recitation videos will be up every Thursday by 10 a.m. So you will have a week's time to watch the video and also fill out the form. It's important that you fill out the Google form every week because that is how you will be marked for attendance. Lastly, when you submit your assignments, make sure that you write the honor code statement which says that you have not sought help and the work is of your own. If you do not write the honor code statement, then I will not be able to grade it. So the purpose of this recitation is to introduce the techniques utilized in converting between hexadecimal, decimal, and binary numbers. We will be going through the following topics, starting with understanding why number conversions are needed, followed by binary to hexadecimal and hexadecimal to binary conversions. Then we will look into colors and hexadecimal notation, followed by binary to decimal and decimal to binary conversion. And then lastly, we'll see the hexadecimal to decimal and decimal to hexadecimal conversion. So the question is, how is the computer data represented? All the computer data is captured and represented in a binary system. A binary system is a system where only 2 bits are used. So the 2 bits are 0 and 1. For the computer, each 0 or 1 is stored in a bit. To be useful to the computer, bits are grouped together into bytes. So when 8 bits come together, it forms a byte. And then the bytes are grouped together into words. Unique combinations of these words have special meanings to the computer and become its instruction. Now, why do we need to do these number conversions then? The human eye can easily misread all these long strings of zeros and ones. So we often convert from the binary numbering system to the hexadecimal system, which is the base 16, or it's also called or 2 bytes. Hence, knowing how to convert between the 3 numbering systems, that is hexadecimal, decimal, and binary, is an important skill. So now let's look into the number conversion table for binary, hexadecimal, and decimal. So here you can see under the decimal column, the numbers are from 0 to 15. And for these decimal numbers, the hexadecimal notations has 0 to 9 as the numbers, and then it is followed by alphabets. So for decimal number 10 onwards, the letters from A are used for denoting it. And for the binary numbers, the combination of zeros and ones is used. So as you can see, for the decimal number 0, the binary will be 0, 0, 0, 0. Then for 1, it will be 0, 0, 0, 1, so on and so forth. So, why don't we play a simple game? It's called the binary conversion game. So we understand binary numbers better. So first of all, start by entering the following link on the browser. Note, some advertisement might be displayed for a few seconds, but that's okay. You can copy the link and paste it on your browser. Then select the classic mode on the opening menu, and then it will explain what the game, the instructions of the game will be displayed. Once you read that, you can start the game. So I will just go through the rules of the game. If there are 3 empty squares on the lower right corner, 3 contiguous bits need to be selected from the left side by clicking on any one of them and then dragging the mouse to select the next 2 bits beside it. If the selection is successful, one of the decimal numbers on the right will be crossed out. Continue selecting bits on the left until all decimal numbers on the right get a match. Then you can continue and move on to level 2 that will require selection of 4 bits, and so on and so forth. So let's go and see this game. This is the game. You can go to classic mode and it will give you the instructions to play the game. You can read the instructions and click on OK. So now you have the numbers. You have to find the numbers 0, 6, 5, 3, 4. So you just have to drag. It's like Candy Crush. I don't know if you've played it, but yeah, it's like the game. You have to just drag 3 bits, and then you can see 0, 0, 0 has been cut. Similarly, we can do 1, 1, 0, and then that is 6. Now that is also cut. So accordingly, you have to select the bits and you have to find all the numbers that are given. So I would encourage everyone to actually pause the video right now and try out the game, and you take the help of the table that was mentioned on the previous slide. You can take help from that table and try to find these numbers. This will be a very good practice to get started with binary numbers. Now, let's start with the real deal, which is the conversions. The first is binary to hexadecimal. Here, the binary number is given as follows, which is 0, 1, 0, 1, 1, 0, 1, 0. Now, whenever we are representing numbers and we have to represent it with their the format that they're written in, you always write a subscript. So here the binary number has a subscript 2 and the hexadecimal number has a subscript 60. So this is how they will be represented. So the binary number is first divided into a group of 2 where each group has 4 bits. So now you can see that the bits are as follows. Now 0, 1, 0, 1 is one group and 1, 0, 1, 0 is the other group. Then what we have to do, using the table that was given in the previous slide, we can check that 0, 1, 0, 1 is equivalent to 5 and 1, 0, 1, 0 is equivalent to A. So therefore, the hexadecimal notation will be 5A. This is how easy it is to convert binary to hexadecimal. Now we'll move to hexadecimal to binary. So you can see here the hexadecimal number is B8. So first we will find B in the hexadecimal column. That is, you have to go back to the table and then you have to check what is the corresponding value of B. You will find it to be 1011. Then you find 8 in the hexadecimal column and you get the corresponding value to be 1000. The binary representation of the hexadecimal B8 is 101100. Now we have seen how to do binary to hexadecimal and hexadecimal to binary. Now the hexadecimal notation can be used to denote colors also. So why don't you go to this website, which is mentioned on the slide, and explore how the hexadecimal notations for the colors are different for every color. So let's go to this website and this is how it looks. So here you can see the RGB values are given and also the hexadecimal format is given over here. If you pick a color, it will give you the hexadecimal format. Like this is how. So if we go to pitch black, then it will be represented as 0, 0, 0, 0, 0, 0. But if you want to see for white, then it will be represented as FF, FF, FF. And accordingly, for different colors, the different hexadecimal notations are given. Now the next topic is binary to decimal conversion. The steps for conversion is to multiply each component of the binary number by its base raised to its corresponding power. So here, since we are converting from binary to hexadecimal, the base is going to be 2. So for the number 0, 1, 0, 0, 0, 0, 0, 1, when we look at the rightmost bit 1, it will be read as base 2 raised to the power 0 because it is the first rightmost element. Then moving to the bit next to it is 0, which will be read as base 2 raised to the power 1. So on and so forth. So if you can see in this table, the same thing is written. The bases are written over here: 2 raised to 0, 2 raised to 1, then 2 raised to 2, 2 raised to 3, so on and so forth. So when you do the conversion, you have to do 1 into 2 raised to 0, which is 1. Then 0 into 2 raised to 1, which is 0. Then 0 into 2 raised to 2, which is 0. So like this, you will get and then you have to eventually sum it all over here, and then you can get the decimal representation. Now for converting decimal to binary, the binary number is divided by 2 until we get a result which cannot be further divided by 2. So for example here, 72 divided by 2 gives a remainder 0. Then 32 is divided by 2, which gives a remainder 0. And the division continues until we reach the number 0, because it cannot be divided by 2, so we have to stop there. So now the resulting binary number is the remainders, but they are read from the bottom to the top and written from left to right. So the decimal number 72 will be written as 1001000 in the binary format. Always remember, you read from bottom to top, but you write it from left to right. So this is how decimal to binary is converted. Now we move on to hexadecimal to decimal. Here we have the hexadecimal number as A9 and we have to convert it into decimal. So hexadecimal is used as a shorthand notation. So first hexadecimal symbols have to be converted into binary. This will be done using the table that we had seen in the previous slides. The binary equivalent of A can be written as 1010, and for 9 it can be written as 1001. So in the binary format, A9 is 10101001. Now this binary number will be converted to decimal as seen before. Every bit of the binary number will be multiplied with the base raised to the corresponding power. So when we do that, we will get a series of multiplication and additions. So here we have seen that the bases are raised to the corresponding power. So now the rightmost element has 2 raised to 0, 2 raised to 1, 2 raised to 2, and then we will multiply it with the binary number. When you sum it, you will get the decimal form. And the last conversion is decimal to hexadecimal of the number 680 over here. So first thing to do is determine how many hexadecimal digits will be needed. Now for doing this, this will be done by determining which power of 16 produces the largest number that is still less than 680. So if 16 is raised to 0, it will give us 1. If 16 is raised to 1, it will give 16. 16 to the power 2 gives 256, and 16 to the power 3 gives 4096, which exceeds the given number, which is 680. So 16 raised to 2 is the largest power that we can use. So now we have the number of hexadecimal needed, which is 3. It's 3 because power of 0, power of 1, and power of 2. We have 3 powers. So that's why it's 3. So now that we have ascertained how many hexadecimal digits we need, we will go on to divide 680 by 16 and then note the remainders accordingly. So if we see 680 divided by 16 gives a remainder 8. Then further remainder gives 10, which is converted to the hexadecimal notation, and so on and so forth is done. So we have the remainder 8, then the remainder 10, which is written as A in the hexadecimal form, and then finally we get the remainder 2. So we get, now again remember that the remainders are read from the bottom to the top, but they're written from left to right. So here we will have the hexadecimal representation as 2A8. So with this, we have gone through all the conversions and we did a lot of concepts. So it is important to understand if we have consumed all of that we have done today. So I've shared a Google form link where you have to answer the questions. But before I end the recitation, I would like to brush through all the conversions once again. So let's go back to the initial conversion, which is binary to hexadecimal. Remember, the binary numbers are divided into 2 groups, which has 4 bits each. And then using the table, we will find the equivalent hexadecimal notation. Then for doing hexadecimal to binary, we will first find the equivalent binary values for the hexadecimal. So if it is B8, we will find the corresponding binary value for B and then corresponding binary value for 8. Then we see binary to decimal. In this, what happens is we will, the base over here is 2. So we will look at the rightmost bit and then it will be raised to, it will be read as base 2 raised to the power 0. Then moving to the next bit, we will have base 2 raised to the power 1. So on and so forth, we will do the multiplications and we will add them to get the decimal. Then for converting decimal to binary, when the decimal number is divided by 2 until we get the quotient as 0, because after that we won't be able to divide. But whenever we divide, we will keep a track of all the remainders that we generate. And then finally, we will read the remainders from the bottom to the top, but write it from left to right. Then going to hexadecimal to decimal, the hexadecimal is first converted to a binary equivalent. So here we had the question of A9. So first we will find the binary equivalent for A and binary equivalent for 9. And then after that, we will convert the binary into the decimal with the procedure that we had seen before. Then we have decimal to hexadecimal. In this thing, first we will determine how many hexadecimal digits will be needed. And for doing that, we will see which power of 16 produces the largest number that is still less than the given number. After we have ascertained how many digits we need, we will now start dividing the number, which is 680, by 16 and note down the remainders. Then we will read the remainders from the bottom to the top, but write it from left to right. So with this, we come to an end to the recitation. Please feel free to email me with any doubts and meet you in the next one. Bye-bye.